want to look at multiplication rules. Multiplication rules are talking about two events. And when we look at tree diagrams, when we talk about these tree diagrams, what we're going to do is we're going to talk about multiplying along the branches. So if I look at a tree diagram, I'm going to take whatever the probability is here and multiply it by the probability here to get this end result. So we take the probabilities and multiply along the path. Now, whatever the branches are for a single event from a starting point, they have to equal 1. Now, they don't have to be equally likely. Like I can have a 2/3 and a 1/3. Or let's say that I break off into 3 branches. I can have a 1/4, a 1/4, and a 2/4. All of these 3 branches that break off from this single point add up to 1. So whenever you're talking about a tree diagram, you want to look at when you break off from a single point, all the branches, the probabilities must add up to 1. And then to get the probability for the entire outcome, you're going to multiply the probabilities along that path from the original starting point. So let's look at an example of this. And we're going to start with the gender of children with 2 children. So we're going to have 2 children. And when we talk about the gender, we're going to talk about just boy or girl. So we have 1 child. And it can be a boy or a girl. So this is our first child. Theoretically, probability of getting a boy on the first child is 1/2. And getting a girl is 1/2. Now on the second child, we can get a boy or a girl. And we can get a boy or a girl. Again, theoretically, probability is going to be 1/2 on each of these branches. So notice that these 2 branches start from the same point, and we have 1/2 plus 1/2. That gives us 1. These 2 start from the same point, adding up to 1, and these 2 start from the same point, adding up to 1. So my possibilities for my outcomes are that I have 2 boys, and the probability for that would be 1/2 times 1/2, which would give me a 1/4, because I take 1/2 times the 1/2 to get the 2 boys. I could have a boy first and then a girl. That would be a boy first and then a girl. So again, that's 1/2 and 1/2, which would give me a 1/4 again. I could have a girl and then a boy, which would be 1/2 times 1/2, which would be 1/4. Or I could have 2 girls. 1/2 times 1/2 equals 1/4. So these are my outcomes, my sample space. So my sample space would be boy, 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 girl, girl, boy, and girl, girl. And then these are the probabilities of getting each of those. Now, based on the tree diagram, what is the probability of getting exactly 1 boy? Well, here we get 2 boys. Here we get 1 boy. And here we get 1 boy. So we actually get 1 boy in both of these cases. We've already multiplied the 1/2 times the 1/2 following this path right here, and then following this path here. So what we're going to do is we can get it this way, or we can get it this way. So that's going to be like we take 1/2 times 1/2, and we add it to the 1/2 times the 1/2, which would be 1/4 time, plus 1/4, which would give us 2/4, or that's the same thing as 1/2 of the time. Because if you notice right here, that's 2 out of the 4 times, so that's half of the time. Exactly 2 girls would be 1/2 times 1/2, which would be 1/4. And then all boys would be the same thing as exactly 2 girls in this case. So 1/2 times 1/2, which would be 1/4. So whenever you're talking about a tree diagram, the biggest thing to remember is that you need to multiply the probabilities along each branch to find out your total probability for that particular outcome. Now let's look at these independent events. Independent events are events where they have no influence on each other. Whatever happens on the first outcome has absolutely no influence on the second outcome. So this would be like I flip a coin one time, and then I flip a coin another time. Whatever happens on the first one has absolutely no bearing on the second one. These would be independent events. So their intersection is just equal to their probabilities, or the probability of their intersection is just equal to the probability of the two multiplied together. We're going to look at some where they're not independent, and it changes up their probability. But if they're completely independent of each other, then we're just going to multiply their probabilities together. Which is the exact same thing with the children, meaning it doesn't matter if I get a boy or a girl on the first child. That technically has no bearing on whether I get a boy or a girl the second child. That is why we can multiply these outcomes, because these are completely independent of each other. Now let's look at sample space for this particular scenario. We have test question number 1 is true, false. Then we answer test question number 2 that has multiple choice with 5 answers. So if I do a tree diagram, I have 2 choices on my first one. It's going to be true or it's going to be false. Then on my second one, I have 5. 3, 4, and 5. I have an A, B, C, D, and E. 1, 2, 3, 4, and 5. A, B, C, D, and E. So my sample space would be true A, true B, true C, true D, true E, false A, false B, false C, false D, and false E. What is the probability of answering true on number 1 and B on number 2? Now, whatever I answer on the first question has absolutely no bearing on the second question. So probability of answering true on the first question is just 1 out of 2. Probability of answering a B on the second question, there's 5 choices, is just 1 out of 5. And so I can multiply these two together, and that would give me 1 out of 10. And if you notice, true and B, I have one of those, and I have 10 total possible outcomes. And so that's what we're looking at whenever we're talking about independent events.